In this video, we're going to take a look at systems of equations. Our very first problem is a bit of a doozy. I'm happy with just one solution to this problem for the review, although there are 6 possible solutions, and I'm going to show you how to find all of them. The end of year test we're going to have is multiple choice, so it'll be much easier to solve this type of problem on the end of your exam than it was on the review. To start though, we do need to begin, no matter which method you use, we're going to need to start by writing 2 equations, and that's what system of equations means. It means we have more than one function happening at the same time. So I have a pizza parlor charging $1 for veggie toppings and $2 for meat toppings, and we want 5 toppings on our pizza, so topping seems to be the common theme here. We have $10 to spend, and our question is how many of each type of topping we can get without going over $10. So we are asking how many of each topping. We're asking how many meat, that's one question. I'm going to go ahead and call that number M. And how many veggie, I'm going to call that number V. So the equations that I write are going to have to do with these 2 topics so that I can solve for these 2 variables, how many meat and how many veggie. So the easiest equation to write talks about the number of meat and veggie. How many meat, how many veggie. So the total number of meat toppings that I get plus the total number of veggie toppings that I get should be at least 5 toppings. So that means it should be greater than or equal to the number 5. I want at least 5 toppings on my pizza. That's my first equation. Now I still have more to do with the meat and the veggie because I also have to consider the price. I have $10 to spend on topping. I want to get as close as possible without going over, so I want to stay less than or equal to the number 10, and it has to do with the price for each topping. So depending on the number of meat, I have to pay $2 per meat topping. And for the number of veggie, I have to pay $1 per veggie. And if I add up all those dollars that I'm paying, I should get less than or equal to $10. So these are the 2 inequalities that I had to write in order to start this problem. Now to find one solution, I can go ahead and solve this using a system of equations. So I can pretty much just imagine, because of these equal signs in here, I can just go ahead and imagine that these are equal to equations, even though they're not. I'm going to pretend that they are, and that will get me one solution out of the many solutions that are possible here. In order to solve this with a system of equations, what I'm going to do is line up the 2 equations. So 2 meat plus veggie less than or equal to 10. I'm going to pretend this is an equal sign. Oops. And I'm going to take the equation meat plus veggie. I'm going to pretend it equals the number 5. So I'm just looking at the equals to equation. And I'm going to line those up. And I'm actually going to solve this using elimination. You could also use substitution. It doesn't matter. I think elimination is easier because I already have 2 variables that match completely in number. 1 veggie on top, 1 veggie on bottom. So elimination is going to be really easy here. So what I'm going to do is I'm actually going to subtract these 2 equations. So I'm going to subtract the meat, subtract the veggie, and subtract the total number at the end. When I do that, I'm going to combine up and down. 2 meat minus 1 meat is just M. A positive veggie minus a veggie is nothing. And 10 minus 5 is just 5. So it tells me that I can buy 5 meat toppings. Now I also need to find how many veggie toppings that would be, so I can plug this number, m equals 5, into either one of the original equations, doesn't matter which one, to find my other number. Now the easiest one to plug it into is m plus v equals 5, and if I plug in m is 5, then the number of veggie toppings I can add to that to get 5 is going to be 0. So one of my possible solutions is that m equals 5 and v equals 0. And that is one of my 6 possible answers. To get the other answers, I can't just use a system of equations. It's actually best to use a graph. And we learned how to solve systems of equations by graphing in Unit 2.3. So we're going to go ahead and take a look at that real fast to see if we can't figure out how best to solve this. I'm going to move this out of the way so I can make a nice graph down here. So I'm still going to have to use these 2 equations, and what I'm going to do is I'm going to solve them for one variable, and I'm going to go ahead and graph them. It doesn't matter which variable I solve them for, so I'm going to start with the m plus v is greater than or equal to 5. Because v is all by itself in both of these equations, I'm going to go ahead and solve for v. So I'm going to subtract m from both sides. The only thing that changes the direction of my inequality is dividing by a negative or multiplying by a negative. So my inequality is going to stay the same direction here. And I'm going to end up with negative m plus 5. And I wrote it like that because it's closest to y equals mx plus b form, which is how we would draw a straight line, slope and intercept. So my slope would be negative 1, and my intercept would be the number 5. I'm going to do the same thing for my other equation. 2m plus v is less than or equal to 10. I'm going to get v alone, so I'm going to subtract 2m from both sides. Again, that won't change the direction of my inequality, so v is less than or equal to negative 2m plus 10. So now I have these two equations, this one and this one. Oop, just the bottom part, please. This guy. Just kidding. Didn't I just, oh my goodness. This is a poor choice. Yay! Okay, I'll bring that over here. So these are the two equations that I'm going to be able to use in my graph. Sorry, that took a minute. Okay. So what I'm going to do is I'm going to graph these guys. So I'm going to have my axis here. Because I chose v for my output, that's the one by itself, I'm going to put my v-axis here, and m is going to be my axis on this side. I'm going to start by graphing my equation in red, which is going to start with a y-intercept of positive 5, there, and it has a slope of negative 1, so it goes down 1 over 1, down 1 over 1, down 1 over 1, so it's going to hit the x-axis here at 1, 2, 3, 4, 5. There. Now this is an inequality, and it says that v has to be greater than or equal to this number. So it has to be above, everywhere above this line. It has to be greater than or equal to. Now my next equation in green here has a y-intercept of 10, and it has a slope of negative 2. So it's going to go down 2 every time it goes over 1. Down 2 over 1. So that would be over here. Down 2 over 1, down 2 over 1, down 2 over 1. So it's also going to touch at this point 5, but this one is a less than or equal to, so it's going to be below. So what you'll notice is what's actually going to get shaded here for my overlap is actually going to be everything between these two graphs. So I have to be greater than the red line, but I have to be less than the green line. So everything in there is a possible solution to this scenario. But I'm talking about number of toppings, and I can't have fractions or decimals or parts of toppings, so I'm only going to be looking for whole number combinations here. Now, this problem is asking for my total price to be less than or equal to $10. And what you'll notice is all the way up here at the top, my price is, this is my total price on the side here, the number of veggie toppings is 10. Each veggie topping only costs $1, so this is $10 total. And that combination has 0 on the meat scale, and it has 10 veggies. Now this is at least 5 toppings, and it equals exactly $10. I'm not allowed to go over $10, but it can be equal. In order to get to the next point where it equals exactly $10, all I have to do is get to the whole number intersection. So I have to go over 1 on my meat scale, 1 meat topping, and that would bring me down 2 points on the veggie scale, 8 veggie toppings. So it'd be $2 for meat, $8 for veggies, and I would end up spending $10 again. And you'll notice that every single answer I get is just the next intersection between meat and veggie on my graph. So 2 meat, 6 veggie, so we've gone down by 2 veggies. We go over 1 more, 3 meat, 4 veggies. If we go over 1 more, there. Next one down would be 4 meat and 2 veggies. And last but not least, this is the solution we found before, which was 5 meat and 0 veggies. All of these are possible solutions to this graph. Everywhere they intersect and get as close as possible to $10 without going over. All right. So I'm happy with just one solution if you found it with a system algebraically, or if you wanted to find it graphically, you can find all 6 possible solutions. But like I said, the exam is multiple choice, so it's much easier to find this answer on the exam than it is here in person. Up next, we're going to take a look at question 5. This question is asking us just to select some constraints that would be applicable to this situation. So we're selling cookies at different rates. The first rate is $1.25 per cookie if you get less than 12 cookies. The second rate is $1 for a dozen. That actually means per cookie as well. We had a slight typo there. That should have been included. So $1 per cookie for a dozen cookies, and then 75 cents each. So you get a bit of a discount if you buy 12, and then after buying 12, you get a whole bunch of a discount. So let's take a look at our first scenario. The first rate is $1.25 for 12 cookies, for less than 12 cookies. So we're looking for a less than 12 here. $1.25 per cookie, we're going to call the cookies X. So 125X when X is less than 12. That's going to be the situation that we have explained right there. The second rate, I already started using red there, so let's do that. $1 per cookie for 12 cookies, for exactly 12. So we're going to be looking for an equal sign there. And then 75 for anything over 12. So we're going to be looking for greater than 12 there. So this is one scenario, so we're looking for one sentence to explain both of these things. So we're looking for $1 times X for equals 12. We have one of those right here. And 75 cents per X when X is greater than 12, which is exactly what's happening. So E is the other correct one. Technically, B has part of the correct answer, but it doesn't explain what happens for the additional cookies. So E is more correct than B is. All right, let's take a look at Jessica. Now, you guys probably recognize this from our review for this unit. Jessica lived in Spain and Colombia for 18 months total. She learned an average of 160 words per month in Spain and 200 in Colombia. In total, she learned 3,200 new words. We're going to have to create 2 equations. Our question is, how long did she live in Spain? I'm going to call that S. And how long did she live in Colombia? I'm going to call that C. Now we're asking how long in Spain, how long in Colombia. So those are our 2 variables that talk about length of time. So let's create our basic equation first. The length of time in Spain plus the length of time in Colombia should equal her total length of time, 18 months. Now we're also going to have to use the time in Spain and the time in Colombia to talk about her other activity, which was learning Spanish. So in Spain, she learned 160 words each month. So if S is the number of months, she learned 160 times S. In Colombia, she learned 200 words per month, so that's going to be 200 times the amount of months in Colombia. And if we add those together, we get the total number of words she learned, which is 3,200. Now, we're not going to be able to solve this problem through direct elimination because I don't have any variables that match exactly. I have the same letters here, but they don't have the same coefficients. The same thing for my Colombia. I don't have the same coefficients in front. So I'm not going to be able to just use elimination. What I could do is multiply the top equation by 160, the whole thing, in order to get the coefficients to match for Spain. Or I could multiply the whole top by 200 to get the coefficient to match for Colombia. But instead of doing that, I'm going to show you a different technique. I'm going to show you substitution instead. For substitution, what we do is we take one of the equations, usually the simpler one, and solve it for one variable. Doesn't matter which one it is. I'm going to choose the top equation and solve it for S. So I'm going to get S alone. So I'm going to end up with the equation S equals 18 minus C. So I move the C to the other side to get S alone. Now this here is what S is equal to. Once I have one equation solved for one variable, I'm going to go ahead and take that variable and replace it in my other equation everywhere I see that variable. So I have S over here. It equals this equation 18 minus C. So when I see S in the equation on bottom, I'm going to replace it with 18 minus C. So 160 times 18 minus C plus 200C equals 3,200. So that's what I decided to do there. So in order to finish this problem, all I have to do is solve for C first. I have one equation with just C in it. I'm going to start solving for C by actually distributing this 160 inside my parentheses. 160 times 8 is 2,880. 160 times negative C is just negative 160C. And then we still have this plus 200C. And it still equals 3,200. I'm running out of room. I can combine my like terms. I have negative 160 and positive 200C. If I combine those, I end up with 40C. And this 2880 plus 40C equals 3,200. I'm going to try and get C alone by subtracting this number from both sides. So 40C is going to equal 3,200 minus 2880, which is 320. And then I'm going to divide both sides by 40. So C equals 320 divided by 40, which is 8. I know C is 8. Now that I know C is 8, all I have to do is plug this C value, so 8 months in Colombia, all I have to do is plug this C value back into either one of my original equations. I'm going to choose the top one again because, again, it is easier. So S plus C should equal the number 18. The C value I just found was the number 8, so I can subtract 8 from both sides to solve for S. S equals the number 10. So she spent 10 months in Spain. All right. We have one more systems of equation problem here. We're going to take a look at this one and then move on to another topic. So question 7 is about Jose using 2 different methods of transportation to get home from school, riding a bike or taking the bus. The graph over here is him on his bicycle, and the equation over here is the bus. All right. So the first question is, what distance does Jose travel to school if he rides his bike? Now that's going to be the graph over off to the right, and it says the distance from school is 4 at its maximum. So the maximum distance that he travels is 4 kilometers. And we found that by looking at where the graph touched the y-axis, which is when our time is 0. That's when he's at his furthest distance from school, when time is 0. So for the second question, what distance does he travel to school if he rides the bus? We're going to take a look at the bus equation, and we're going to try and do the exact same math. We're going to be looking for when the time is 0. The time is the letter t in this equation. So what is the distance when the time is 0? In this case, 0 plus 5, the distance would be 5. So 5 kilometers. The last question is, which mode of transportation takes less time to get to school? So this time we're going to be comparing time values. The bicycle, by the time it gets down to no distance at all, the time is 16 minutes. So the bike takes 16 minutes. We need to find out how long it takes the bus. Now, there was a small typo in this equation. The 1/3 should be negative. So without the 1/3 being negative, we're going to get a number that's negative, and that's going to look a little bit weird. But the value of the number is still going to tell us which one's faster. So let's go ahead and take a look anyway. So when we're looking for the time, we're looking on the x-axis, which is when y equals 0. The distance is 0. So by the time the distance to school is 0, that means he's at school. We're going to try and figure out what time that is. So this time we're going to take the distance and set it equal to 0. And take a look at our equation here, 1/3 t plus 5, and we're going to solve for t. We're going to have to subtract 5 from both sides. 1/3 t is negative 5. This is where the weird number comes in. It shouldn't technically be negative. And then we're going to get the 1/3 out of there. 1/3 means dividing by 3. We're going to go ahead and multiply both sides by 3 to undo that. And it looks like t is going to be negative 15. Now, if the 1/3 was negative like it should be, this should end up being positive, but what we're going to focus on is this number right here. It takes 15 minutes on the bus. So the question is, which takes less time? The bus takes less time. It is 1 minute faster. There we go. So that's it for our systems of equations questions. We're going to move on to topic 3 in the next video.